Hi, good evening. So today I want to stream a new idea I have for data from analysis 1. I'm gonna listen to some music and make sure that it's not playing. Okay. Alright, so let's move this over here, get our chat box out so that I don't miss any chats like I have in the past. Get out of that. I have to go get my coffee. Okay, I should have done that before, but I'm officially ready. So here's the data set we're working with. And if we go to this analysis, basically what I was looking at was wins and losses for the home team. You can watch the video I posted yesterday where I get my first successful analysis going on that. It returns positive for every year going back to 2014 when I use at least 7 training years. So let's go back into that folder. The folder I was using to make that. So analysis 1, and if I look at the classifier here, I was looking at this because this is the thumbnail for my YouTube video. I was looking at this, and really it looks like there are these two different trend lines. And this trend line in particular really looks like it's all away teams. So the first thing I want to do is try to fit these two trend lines and then see if there's any, like one trend line away team wins, one trend line home team wins. That would be the simplest case, but my real hope is we're using a Gaussian classifier, so I'm hoping that this could maybe improve the results from the Gaussian classifier. So what I want to do is I want to just give it this data to look at, and I'm hoping that it will find this line right here, and then also this line is a secondary line. So I'm going to open a file to do that analysis here. New file. Need to open the right folder. Open folder. Spread history data. There we go. I trust the authors because it's me. Alright, now we have analysis 1. Get analysis, plot analysis, test region type, analysis 1, trend 3. Okay. So we have a class for analysis 1, trend 3. We're gonna, so let's add here another trend that we're looking at. Can't F11 full screen PowerPoint. Huh, that's funny. Okay, so let's do analysis 1. Trend 4 is the data appears to follow 2 different linear trend lines. We could put our picture in. Okay. Crop. How do we crop? Crop. I want to crop this. Oh, there we go. Okay. Now I just want to highlight the trend lines that I'm talking about. Okay, I'm gonna make that thicker so you can see it. And maybe red would be good. Okay, let's put another one in. Okay, cool. So those are the two different lines we're looking at. Now we've documented this so we know what we're talking about in here. So let's make a new class for analysis 1 trend 4. This is honestly just confusing. Let's just make a new file. Open file. Analysis 1 trend 4. Oh, I need to make a new one. Duh. New file. Analysis 1 trend 4. Okay. Oops. .py. Cool. Okay, so let's make a description real quick. File for fitting linear trend lines to data. And then I'll just have to pull in the read data stuff. I don't know what's going on there, why it indented it. Probably thinks it's in a function or a class. So back up here, how do we read the data in? Get analysis, wins losses equals get analysis. Okay, so this will be the same for any more bad news. Alright, so let's copy that, put that over in here. Now what do we need? Alright, there's not referenced. Coming after whoever who has it. Coming after whoever who has it. Alright. So let's just do get analysis. df is equal to, okay, now we want pandas. So import pandas as PD, and then df equals pd.read csv. What's the file called again? Data/data, or is it just in data? Spread history data. Oh, yep, data. Data.csv. Data.excel. Oh. Close window. Get that out of here. Don't save. Alright. Dot read xlsx. Or is it read excel? Cool. Data.xlsx. Get analysis of df. Wins losses is equal to, and then let's just put the debugger in there. from PDB import set trace as st. Okay, now let's go run the file. Make sure it's saved. Just gonna get a feel for, I haven't worked with this in a while, so I'm gonna get a feel for what wins and losses looks like. Analysis, I'm living in that 21st century. Analysis 1, trend 4, okay. Come on. Too many values to unpack. What does that even mean? I don't even know how that makes sense. Wins losses equals getting. Too many values to unpack, expected to. And you got to. We ain't got nothing to lose, motherfucker. We rollin'. Just do the same thing. Huh? I'll see you in the morning. Yeah, that doesn't make any sense. What the hell? Equals get analysis, df. Fuck that, the world's ours. Wins, losses. Oh. Wins, losses. Win odds, lose odds. Okay, what's that look like? Come on, come on, come on. Yes. Wins, what's that look like? 9 body, every characteristic of the egotistic. Fucking gifted. Alright, win odds. Alright, so plot analysis, wins losses equals that, data plot plt.figure. Okay, let's just put that in too. Copy plot analysis, fuck that, the world's ours. Fuck. Plot analysis, come on. Powers, Austin, Powers, lost in translation. Alright. Don't want to miss out on that. Okay. Need to import the packages we need. I was drinking earlier, now I'm driving. Get analysis, plot analysis. So let's just get rid of that. Now we're just gonna say plot analysis down at the bottom. Plot analysis. Years. Let's equal that same shit I put up here. That thing. And this would be a beautiful death. Alright, I'll put that there. Now what's the issue here? There's no data frame. Get analysis, data frame. Do I put in the data frame here? Yes, I do. So let's just put, get rid of that. Copy that and just put it back up at the top. Okay. Now let's see if that will run. Nice. Alright, so that's plot. Okay, so we've got that. Now we basically just want to get the data. So xmin, xmax, data equals wins. Oh, so you just scatter wins, then you scatter losses. Alright, well that's easy. So go back to that. Now we can scatter them. How do you scatter wins and losses? That's what I don't understand. Because it looks like it's just one value each. And again, I should be comfortable and familiar with this code so it doesn't give me issues. Oh, oops, I shouldn't have passed through that. Exit, exit, run it again. Now wins. Wins dot values. Wins of 0 dot values. So that must be, so for home team wins, that's just, okay, so this is just the away change in odds. Point. So wins of 0. Okay, so let's think. The 0 column of each is the swing for the away team, and the 1 column of each is the swing for the home team. So points. If you want it, you can get it for the rest of your life. And I'm just trying to think. So we want to scatter all points, and then for each point we want to get the distance. Wins of 0 dot values, comma, what if we zip them together? Zip wins of 0 dot values, and then wins of 1 dot values. Okay, let's just do I for I in that. Oh yeah. Alright, so win points equals that. I for I and zip wins of 0 dot values, comma space, wins of 1 dot values. Alright, and then those are win points. Now loss points is the same thing except losses instead of wins. Same thing here, losses. Alright, now we have win points and we have loss points. So we have every point, so all points. And we could kind of get rid of that for now. Actually, don't need that whatsoever. Okay, now all points is just win points plus loss points. Okay, now so we have all of our points. Now we just have to, let's go up here from optimize, from scipy optimize import differential evolution, which is my favorite optimization algorithm because it's so general you could apply it to anything. So that's what we're going to start with. Now, okay, so the first thing we're going to want to do is define a function that we can optimize. That function's going to get some parameters passed in. The parameters look like so each line has an x-intercept, so x int m1, b1, m2, b2. So those are just m and b, a equals mx plus b, or y equals mx plus b for the linear relationships. So those are the params. Now line 1 is equal to we want to get the distance of the point, each point from the line. How to do that? Distance between a point and a line. Here's my video. Point and a line is the shortest distance. Okay, so do you have numpy in here? Yep. So here's what we do. We do ax that was confusing. The AI stuff really doesn't help very much. Distance between that line and that point x plus by. Okay, let me think. So if it's ax plus by plus c equals 0, that's just by equals minus ax minus c. Okay. Okay, so the first thing is rearrange the line. So ax plus by plus c equals 0. So in our case, b is equal to 0. B equals 1. So then we just get y equals minus ax minus c. So a minus ax. So a is equal to minus m, and then c is minus b. So equation for distance between a line and a point. Shapely. Can't we do that in Shapely? Python, how to measure distance using Shapely. Come on, Shapely. Yeah, I don't know, that looks confusing. So back to this. Equation for distance between a line and a point. The point on this line which is closest to that point. Okay. So now, to get the closest point on line to point in question, you know what, let's just put all this here in its own function. Define distance between point and line. Okay. So we want A for the line, B, and X and Y. Okay, now paste all that stuff in. Now closest X is equal to B. Yeah, so first let's do so C is our negative B, so B is equal to 1, A is equal to minus M. Now instead of, because we don't use A equals mx plus B. A equals minus M. A equals mx plus B. Yeah, I mean, whatever. So here, mx plus D. Y equals mx plus D. Now B equals 1, now C equals negative D. Minus D. Now I am headed home. Alright, so now we have those defined. Now we could say closest X is equal to B times X minus A times Y. Okay, minus A times C, and then take the whole thing, am headed home, and divide it by A squared minus B squared. Okay, and then similarly we could get closest Y is equal to A times minus B times X plus A times Y minus B times C. Divide that whole thing by A squared plus B squared. Cool. So we have closest X, closest Y, and then distance between 2 points. I just want to look it up to be totally sure. Distance between 2 points. Voila. Praises due to the most flapala. Okay. Where the hell's Wikipedia? Come on, yo. Alright, root of blank blank. Yeah, that should be fun. Okay. Return. Take the root of that. So, and then inside the root, we're doing blank plus blank. Each blank is squared. And then inside the blanks go x2 minus x1, y2 minus y1. So closest x minus x, closest y minus y. Okay, then we can say distance between points and lines, and the line okay, so let's just put the line y equals 1 plus 0, and then the point is 5, 0. So The distance should be 5. Divided by 0. A squared minus b squared. A squared minus b squared. Well, b is always equal to 1. A squared minus b squared. Oh gosh. So if the line yeah, that doesn't help, man. What if you do, what if, I'm trying to think, a squared minus b squared, b is always going to be 1. So if the slope, dang it. Maybe there's a way in NumPy. Division by 0. So the division by 0 occurs because b is the same as the slope. So what do you do if that's the case? You just can't find, I don't know. I don't understand that at all. I just want to get the distance. Oh, I guess we just need to do a least squares. Hey, nice. Solve a nonlinear least squares given the residuals. Least squares finds a local minimum. No, we just want to get the least square. Compute the least square solution. Left hand side array. Let's see, how does this work? Linear least squares with non-negativities constraint. Input. We want to define a quadratic polynomial. We first form the design matrix. Yeah, I don't know what that means. Least square. Okay, let's mess around with it, I guess. Python 3.8. From scipy.linalg import least square. Alright. We want to fit a quadratic polynomial of the form y equals a plus bx squared. We first form the design matrix with a constant column of 1s and a column containing x squared. The way you look should be a sin, you my sensation. The design matrix. Alright, so let's do that. Okay. Fine, yo. Now, raise it to 0 is good, but here we just want to raise it to 1. We want to find the least squares solution to m dot dot. What's p? No, that's not. Well, I don't want to do a least squares fit. Could it be more Tony? Yeah. I don't. That does a fit. I don't want to do a whole fit. Well, I mean, it works. Oh. What did I do? I tried to fit a linear fit. So instead of YY, it's just that. Very nice. Okay. So how do we fit two linear lines though? That's where it gets complicated. That's why I want to do my own thing. I just want to do the least squares. Ugh. Before his jaw shattered climbing up the Lord's ladder. Let me think. I guess we could just get the vertical distance. I'm not really thinking quite well. Okay, let's go back to optimizable function. Now we have these params. Now for points and all points, distance to first line is equal to, alright, so first we want to get whatever the point is, the line point evaluated at x. So we just do distance to first line is m1 times 0.0, m1 times the x plus b1. Alright, so now we get that y, and then this is just the m1 times point of 1 minus the y value there. That's just that, and distance to second line is the same exact thing, but M2 and B2 instead. Just 0.1, yep. B2, M2, and that's just 0.1. Alright, cool. Now, so now we just want whichever one of those is less. So distance is equal to min distance to first line, distance to second line. Get the minimum of those, then SLS is equal to 0. Then here SLS plus equals distance squared. All right. Differential evolution. From bounds is equal to, now the bounds on M1, what's the max it could be? Let's see, so both have a negative slope. Both have a negative slope. Zero to -2, -4. Could let it vary from 0 to -4. M1, so M1 can vary from from -4 to 0, min to max. B1 could vary from what should that be? That should intercept about 0. 500 plus 500. And if that to get crazy, can't she just run away? Run away fast as you can. Okay. Now let's see what happens when we try to run that file. Okay. How do we get the output of the differential evolution? Cause the look in your eyes is killing me. Print diffy. And I always find something wrong. Well, that's interesting. So the second line had a slope of 0. Alright, so then we want to plot it. Alright, so then so how do we scatter that? Data for plt.scatter data equals then alright, now copy, oops, copy that, and alright, so now I'm just trying to plot the data to see how the fits look. Obviously one of the fits is bad because it has a slope of 0, so yeah, just want to look at these and see what they look like. Okay, so let's plot it. Damn it. Mixing. Oh, duh. Cha. I mean, there are two different lines. Maybe we could isolate them if we zoom in. So maybe cut out all data that isn't between minus 50, minus goes more in that direction. It does look like that. There are two different trends. I think we could pick them out. Have you lost your mind? There's just so many points. Okay, nice. Yeah, I mean, it still looks like this is a line, this is a line, and this is a different line, but I don't know how to fit those unless we just isolate data between 50 and 50. Now we say if I for I and zip alright, now let's just put st here. Comment out all of that stuff. Hide the plot. Okay, so when all points. Okay, so then we could just say all points is equal to point is equal to I for I in all points if I of 0 and I of 1 if I of 0 is less than 50 if I of 0 if np.abs of I of 0 is less than 50 and np.abs of I of 1 is less than 50. So now we're just getting all points in that small region. Get that out of there, and then take out this comment, and let's see what the plot looks like. We should just be optimizing to that region now. Come on. Oh, very good. Not the best. Plot. Okay, let's go back to looking in there, hide that stuff. Okay, so now we just want to plot all points so that we know we're not plotting any points on accident. Wins equals We could just try scattering all points. Game for sure. I have 0 for I in all points. All of the lights. Okay. That's interesting. Okay, so maybe the bounds are too big. Okay, so let's change the bounds instead of instead of 1,000, we're gonna do 50. Okay, now oh, and what's the other thing we want? Oh yeah, minimize the bounds. Bounds. Okay, so you got that trend line. I just wonder why it's really only fitting 1 trend line to the data. So maybe the problem is okay. Maybe we'll just do that and just add them up now. Okay, get rid of that now. Get rid of this. Okay, let's go look at what that looks like. Color for the real data, let's make it red. There's another one. This is interesting. Why are the lines coming up so far away? And why is that the best value? Seems like you would get way better values getting down there. Maybe it's just these it might be these are artificially weighting the points. I don't really know, but there's so many points here that that should make a bigger difference. Distance from the point. Oh, that's why. Because we're adding the distances together. Okay, so now we want the absolute value. Okay. Now let's see how that looks. I think that should fix the problem, because now we're dealing with the absolute distance and not that way the negatives and positives won't cancel each other out. That looks good, but we're still matching the total trend line. Those are going to be the same exact line. And the fit is just, it's the same line. Okay, so now let's do, what do we want to change? We want to increase the bounds, or, so now we want to change it back to the minimum distance between the two lines. So hopefully that lets us find a second line. Where? Okay, let's see. Do we have any? We got one view. One view an hour ago. Cool. How cool, man. And that took a while. Oh, good. Now we did it. Yep. That's what we were looking to do. Very good. Let's make that a different color, not red. Lib colors. So the first line, let's just do cyan and green. Cyan and green. Cyan and lime. Okay. Okay, this color is going to be lime. Just waiting for this fit to finish. And then it should look good. We could throw it in a PowerPoint and be done. Okay. Okay, now let's go put that in our PowerPoint. Two lines fit well. Yeah. Okay. Okay, that's what the two lines look like. Now when we okay, now you say the fit works when using a differential evolution algorithm to fit algorithm to fit the data, and focusing on data with an absolute value less than 50 on either axis. Code in, what's that code file called? Where is it? Code in analysis 1 trend 4.py. Cool. All right, so I basically achieved what I set out to do this live stream. Thanks for watching. Please go watch my videos doing Python embedding analyses, or if you're interested in bikes, I have videos about that too. Yeah, that's basically it. Thanks for watching. Have a nice day.